Finally, for this session, we have Wimarshi Jayathilaka with her PhD Managing End-of-Life Solar Photovoltaics in Achieving Circularity through Blockchain. Thank you, Wimarshi.
Good morning, everyone. I'm Wimarshi. My supervisors are Dr. Nao, Dr. Daniel, and Prof. Jian. I'm from University of Adelaide, and my research topic is managing end-of-life solar photovoltaics in achieving circularity through blockchain. Before I start, I have a question for you. Do you have solar panels in your houses? Yeah, probably. Yeah, you have. So if you have solar panels in your houses, I know you haven't thought about, like you haven't thought about how to what you are going to do at the end of your solar panels life cycle, because most probably your solar panels are in the early stage of your solar panels. But there was a solar panel boom in early 2000, and most of the solar panels were installed in that era. And normally, based on the industry practice, the life cycle of solar panels are around 25 years to 30 years. And most of the solar panels installed in this era are now becoming to end of their life cycle. That is why this topic is important. Most of the media actually reported about this issue. In Australia also, we have the same issue. Most of the solar panels are reaching their end of life cycle. So first, I will give you the background for this issue. As you can see, um, in the world, among all the other renewable energies, solar power is the leading renewable energy. And most of the countries are using this solar power, including Australia. Due to this increased use of solar power, solar panel installation is also increasing, and solar panel waste also increasing. The issue is these solar panel waste are hazardous. Therefore, most of the researchers are looking about the methods of solar panel waste management. And there is another issue. There are the lack of incentives as well as lack of tracking of the solar panel waste. So I'm looking about how to track the solar panel waste. So this is the Australian context. As you can see, again, in Australia also solar panel waste are increasing. These are some regulations, policies, and acts at the moment in the country around the world. If you can see, European Union already has some solar panels, specifically solar panel related regulations. Australia also has classified solar panels under e-waste. And these states, Western Australia, South Australia, Victoria, Queensland, as well as Australian Capital Territory, already banned solar panels disposal into landfills. So the circular economy aspects of this solar panel waste is, if we can think about solar panel waste with circularity, we can reduce the disposal of solar panel waste into landfills and recover the valuable material of this waste and reduce environmental impact and create economic benefits as well as job opportunities and reduce the impact on humans, as well as we can comply with the regulation. So this is the supply chain of solar panels. As actually I have I have mentioned only the main three stakeholders within this supply chain: supplier, consumer, and recycler. But we have other stakeholders as well: installers, transporters, regulatory bodies as well. So at the end of the solar panel life cycles, most of the solar panel waste are ending up in landfills, or else a very small amount is going through recyclers to recycling, and most probably the remaining solar panel waste are ending up in improper disposals. So due to this, there are many impacts on the environmental and the human, as well as we have supply chain issues and issues in waste collection and transportation. So if we have proper tracking and monitoring system, we can find a solution for this one. But for proper tracking and monitoring, we need the digital technology. So what is this digital technology? Through a systematic literature review, I was able to find out blockchain is the ideal solution for this issue. Actually, blockchain is a decentralized, digitalized ledger system that we can store all the data. Therefore, my research comes to the stage and managing end-of-life solar photovoltaics in achieving circularity through blockchain. These are my research questions. Based on these questions, I was able to identify my research aim and research objectives. Then my research aim is design an innovative blockchain prototype system to promote circularity in managing end-of-life solar panels. These are my objectives. Explore the existing literature on incorporation of blockchain and circular economy in end-of-life solar panel management. Then I'm going to answer my first research question through this. And my second objective is identify benefits, drawbacks, and of blockchain technology in end-of-life solar panel management. And I'm going to answer my second research question through this objective. And third objective is develop a conceptual framework for incorporation of blockchain technology to support circular economy in end-of-life solar panels. And I'm going to answer my third research question from this one. And fourth and fifth research objectives are develop and test and validate my prototype system. And I will be able to answer my last research objective. So this is the research process I'm planning to follow. This research process has three main phases. First one, literature review. Second one, data collection, analysis, data model development. And the final one, develop, test, and validate my prototype system. So the first research phase include the background study, literature review, and document review. And in the second phase, I'm going to do some in-depth interviews with industry practitioners. And finally, I'm going to test and validate my prototype system. So these are the significance of my research to academia, method and practice. This research will provide broader knowledge on circularity in solar panel waste management using blockchain, and it will provide innovative, practical way to track and monitor solar panel waste. And of course, this will provide a practical solution that implement among solar panel supply chain stakeholders involved in solar panels supply chain, as well as including the government agencies. Also, this research will align with United Nations Sustainable Development Goals such as 7, 9, 11, and 12. This is the way forward of my research. Now I am doing some research in Australian, sorry, not research actually. I am studying about solar blockchain in Australian Computer Society because this is the first time I am using blockchain. And I am learning about Hyperledger Fabric platform as well, because this is the platform I am planning to use for solar panel blockchain system in solar panel waste management. And I'm looking forward to collaborate with the industry, because I need the help of the industry to develop my blockchain system. I need data for my blockchain system. And thank you very much. If you have any thoughts related to this project, it will be really helpful for me. So thank you very much for listening.
Hello, very interesting. To answer your question about do we have data, I'm like architects, probably not the right people to ask, but we can definitely put you in contact with people who would be able to. But my one interesting question I have which might tie this into having a larger impact is there any reason why this couldn't work for solar batteries? No. Is there any reason why this couldn't work for door frames or roof sheets or other building elements?
No, this system, based on the, thank you for the question. Based on the data that we are feeding for the system, we can use it for any kind of.
Right. So I think one of the major challenges for this is getting enough parties on board to participate in that blockchain. Yes. And if the effort that goes into that is only put in for solar panels, that effort could be, I'm trying to think of it, it'd be limited, right? But if that effort was put in for multiple building components, then now you've got such a larger gain on return.
Yeah.
That's one interesting point I'd like to make. The second one is retroactively implementing the blockchain. So I think it's quite simple for us to go through and put blockchain on whatever gets installed from now on and forever. But how do we implement older photovoltaics into the blockchain system? Who owns the signature on that element? And so therefore we don't get the gains of the work that you're doing in 30 years time, we get it next year or whenever you finish.
Actually, using for solar panels, using the serial number, if you feed the serial number, you can see everything. But I'm not sure about the other components, because if they have any identification, you can use that identification, that ID in the blockchain system to get the data. But in this point, this blockchain system will be benefit to manufacturers and recyclers, because they are the one who play the major role within this system. And actually I'm preparing prototype system. I'm developing a prototype system. If it works with the solar panel waste, then probably we can use it in the other industries as well. Yeah, if it works, we can probably open it to the general public as well, the consumers, so they can use it as well. So then anyone have the ID, they can use the blockchain system. Thank you.
Thanks, Wimarshi, it was really clear. So just a follow-on question. So who holds all the serial numbers? How do you get all those serial numbers? And if the serial numbers give you everything, why do you need the blockchain?
Actually, serial number only gives the data, the date, manufacturing date, and the life cycle, who the manufacturer is. Only very few details. But through the blockchain, you can find out if I'm the consumer. If I enter my serial number, my solar panel serial number, then I can find out the nearest recycler for me at the end of life cycle. Where do I need to go to recycle? Or
this is if you own the panel.
If I am the and
what's the incentive for? I mean, there'll be loads of data with the installers, right? They will have data on all their customers forever. You'd like to think, if only through the invoicing system or something. So what would be the incentive for them, and what would be the incentive for the actual end users who have these panels?
Actually, I was able to have a quick chat with manufacturers, one manufacturer and one recycler. The issue is the manufacturers in Australia, they don't know where their solar panels are going at the end of the life. They don't think about that. But through the blockchain system, probably manufacturers and recyclers can get together, and they can have like a mechanism that they both can be benefits of, because the manufacturers can contact the recyclers, then they will be able to like work out through these solar panels. Then probably they will have the chance to like get some profit from the recycling, both the manufacturer and the recycler, because at the moment in Australia, actually I probably think in other countries also, the manufacturers from the other countries also not thinking about the recycling because they are doing manufacturing only. But through the blockchain system, they will be able to what we call it, um, uh, give like find the a way to recycle their own solar panels and find their own recyclers for their
So it'd be very interesting if you're able to interview them and find
Yeah.
out the veracity or otherwise
Yeah.
of these sort of
Yeah.
suppositions about.
Yeah, but
Okay.
actually, I was on at this moment I haven't interviewed anyone.
Yeah.
Because after my ethics approval, I will be probably able to contact them and get their thoughts.
Great, thanks.
Thank you for the presentation. It's really interesting to dive into this topic of e-waste and solar panels. I have two quick questions. The first one is actually a bit similar to the previous one. And so when you were talking about circular economy a lot, and you're creating this cycle and want to use blockchain to like track and monitor, but in my understanding, a circular economy is a lot about policy making and the top-down relationship of how to implement the whole recycling system. But you didn't mention a lot just now to include stakeholders or like communities or the users. So how do you think the blockchain or the system that you're going to create could benefit the policy making, or like how to introduce it to convince people to believe that it could benefit the circular economy? And the second question is that just now you were saying the system is for the tracking and monitoring before recycling, but a lot of e-waste actually after handling to the recycling is exporting or going to another country. And would you also consider to do something in the recycling process or after the recycling to really know how the material is going to be regenerated instead of just going to the recycling and then stop, in order to have like a full cycle of really using the material in a good way?
Thank you for the question. For your first question, actually, at this point, I'm not considering about circular economy as the main what we call main aspects, but through this system, I'm hoping to enhance the circular economy, because because as you said, most of the solar panel waste are sent in into other countries. Actually, in Australia, the majority of the solar panels are waste are going into Africa, the other countries. So if we can, and the remaining are going into landfills. So if we can reduce the solar panel waste going into landfills, and if we can recycle, then we can enhance the circularity, because through that. And the second question, yes, how I'm going to convince the people to use this system. Again, solar panels that installed in early 2000, those people may not have the idea about how they are going to recycle their solar panels at the moment. So that for that we need the help of the government as well. Actually, New South Wales sees stepping forward to develop product stewardships. Through these things, we can like inform the people, inform the public that you have the different kind of methods that you can use to recycle your solar panels. Yeah, yes, thank you.
Thanks for the presentation. It's a very interesting topic. I think something you might also project into the future a bit and think about is the infrastructure requirements for running a full blockchain. Something like Ethereum at the moment runs at about 1.4 terabytes, which makes it very difficult to run a full node in a distributed way. So then it's like, well, am I going to run it in the cloud? How much does it cost to host 1.4 terabytes blockchain in the cloud? Do you have, if it's distributed globally, do you have to have multiple cloud locations and sync between those sorts of nodes? So yeah, maybe sort of also look at like, what is the cost going to be to run a full system, and what sort of size do you think this could potentially get to if you start integrating other things, more than just solar panels, for example?
Thank you for the question. Actually, since I'm developing a prototype system, I actually haven't thought about much about those things, but I should think about those things as well. Yeah.
It's the same question happened 3-4 times. It's about justification why you're using blockchain, because you're in early stages of your research. It's very complicated, sophisticated financial technology, or about the security of the finance. So maybe you need to take some characteristics of the tracking system and consider system like blockchain, not actual blockchain. It's heavy, cloudy system. So just consider something similar, maybe to make it practical and be more useful.
Thank you.
Just to jump off that comment, have you looked at facilities management systems that the building managers use? Because they do a lot of what you're looking at, but within a closed system. And so, like, if we look at what was just mentioned about Ethereum and like money exchange, blockchain's almost necessary because there's just so many potential purchases and whatnot happening in a very short period of time, versus like a facilities management system will target all the various things that you're trying to solve in regards to solar panels, but it only does it for like a particular building manager. So how do you take a system that is designed within a closed environment and distribute that across Australia? You might not even need blockchain, if that makes. I think that's what we're. Yeah.
Also jumping on your comment, beside the facility systems, consider like the freight companies like Honeywell, and they have like wider logistics. I know they use for tracking like Snowflake as a system for like global tracking system. So yeah, it's worth checking out the system.
Thank you.
I should go down, so yeah. I agree with like I think overall it's a very interesting presentation, and you've kind of got two topics, because you've got the cycle of the solar panel, which I probably have a few questions about that, and how much of the solar panel is recoverable, what the finance return of getting those elements from solar panels are, and on the other side is really, I think blockchain is a hot word, and it's kind of brought into many researchers, but And there are elements of the financial concept of blockchain that, of course, you can relate to. But in a way, we're talking about the physical environment. So as soon as your solar panel, your photovoltaics get out of the manufacturing, it's a serial number. So the tracking you do could be digital on some kind of database, but in reality, the transactions that happen after that are quite minimal. So probably you'd be looking at some kind of RFID technology or like a net tag to understand where the location of those elements are, and that would give you enough information to actually get the tracking. Those, of course, could be connected to a database that could be blockchain-like structured, but yeah, I don't think you would need much cloud investment to keep that running, because it would be pretty basic. I think overall, yeah, very interesting, but you kind of have to focus on what technology, how you actually tracking who is actually, because you don't really need to track every element, I don't think, for your research. If you get like a few elements pop up on radar, you get an idea of where the problem roots are. Yeah, so yeah, more a comment than anything, but yeah, interested.
Thank you very much.
Just hoping to draw on the questions so far, but just wondering if blockchain is obviously a ledger, and it's not as dynamic as, say, financial mediums in blockchain, as mentioned. So, is there once you define whether it's a blockchain or another ledger type, a database, have you thought about using GIS or connecting to some of the previous presentations this morning, where obviously currently solar panels are all exposed to the sun, so using geolocation as a starting point, and you mentioned the policy frameworks in Australia avoiding solar panels going to landfill already. If there was a layer to that any panel with a current geolocation, which is a legacy panel, has to then be entered into the database once it is removed, meaning your contractor within their contract has to engage with that database as part of policy framework. Is that possible? And you can then rely on your own data gathered from satellite scans, which can be updated, every day if you like. Just wondering if that's one. And then generally a lot of the investment in solar is from quite centralized sources. So could you go to the investment sources and then extrapolate to the major solar panel production lines, which are China, Mexico, maybe one or two others?
Thank you for the question. Actually, when I was doing my systematic literature review, I was able to find out GIS related research as well. But for this my blockchain system, I actually haven't think about incorporating any other technology with blockchain, but probably I can think about that as well if it is benefit to the research. And the next one, when I am doing my interviews and when I'm doing my ethics, I probably going to think about the overseas manufacturers and investors as well. Yeah. Thank you.
Hey, Wimarshi. I really liked the way that you set the problem out. You've identified a very key waste source. I think it's really important. It shows impact as well. It's kind of it's a good way of showing impact. You talk about impact in academia a lot. I'm not going to talk about the ledger side. I think there's enough said on that. But I do think when you show a diagram of the circular, or the current material process, I do think you need to go into a bit more detail and show how circularity actually will happen. And I think there have been comments on that as well. But to say it ends up in recycling and just kind of magically expect us to think that that's going to be circular isn't going far enough to really convince us that then the ledger is the solution to the problem. So I wonder whether in future presentations, a kind of a system drawing, really trace up. Really interesting that it goes to Africa. What does it get used for in Africa? Does it go into their solar panels industry, or where does it go? I think it'd be really, really useful, because then you can make a stronger claim, because at the moment, quite a few questions coming out of it.
Thank you.
Yeah, I think on that note, it would be also quite interesting for you to specify in more detail what actually determines the end of life of a solar panel. Once it's cracked or distorted, that's okay. But if it would not be damaged in the regular sense, you can see a mechanical impact on that panel. What does it determine then that that's the end of life? Is it that the solar panels just lose the efficiency and then therefore maybe they can be shipped to other countries because they don't really care that much? Or what's the what's the incentive there to say this is the end, you need to purchase new ones?
Thank you. So if I get your question correctly, so when it sent to other countries, because Australia is actually doing this a lot, because they need to get rid of the solar panel waste. So they are trying to send it into other countries. They are doing it. So in other countries, they are going to do it. Most probably, they are also sending those into landfills in their countries. And I should as Chris said, I need to think about the circularity as well. Since I'm in the first year still, I need to think a lot about how I'm going to engage a circular economy into this one. Yeah. So, I'm not sure whether I answered your question.
It's more about, what determines the end of life of the panel? Why is everyone saying after 25 years the solar panel is broken and it's not working anymore? Because they still are, but they're not as efficient anymore. So why should we replace them even though they're working?
Okay, it means whether we can repair and use it.
You only need to repair if they're or malfunction. But if they still work and produce energy, maybe not as much. You're reducing the return of energy to 60%, but it's still worth it.
Yes.
I think time's up. Also because we have tech support here to fix the problem, but of course, since they arrived, the screen hasn't. Do you want to just be here the whole day?
It's definitely, it will happen.
So thank you very much, Wimarshi. So we now have a break. We've got some tea.